Hello everyone, today we are going to discuss another important topic which is about tautomerization or tautomerism. Tautomers are the constitutional isomers of single chemical compound that are readily interconvertible chemical reaction converting the two is called as tautomerization. This conversion usually results from the relocation of H plus ion and the two isomers exist in dynamic equilibrium with each other. So in tautomerism, the two isomers are present in dynamic equilibrium with each other and are represented by two arrows in opposite direction, which actually represents the sign of equilibrium. So the question is how tautomerism is different from resonance. And the answer to this question is quite simple because the tautomers are two distinct species that can be differentiated on the basis of their atomic connectivities, molecular geometry, and physicochemical properties. They also have different spectroscopic properties, whereas resonances are merely alternative Levy's structures of a single chemical compound. We will say that tautomers are different from resonance because they can be differentiated on the basis of different atomic connectivities, molecular geometry, physicochemical, and spectroscopic properties. While the resonance structures are merely alternative Levy structures. discuss an example of atomism. And as you know that amino acids generally exhibit the phenomena of tautomerism. So let us draw structure of amino acid. So in this case, as you can see that we have H plus that is attached in the form of hydrogen atom within the hydroxyl group. So this is basically called as the C terminal of amino acid, while this one is called as N terminal of amino acid. Now what actually happens is that this H plus will relocate itself and will be transferred to the NH2. So the NH2 will give rise to positive charge in the form of NH3 plus, while the C double bond O negative will get the negative charge. Now we have shown its resonance structure. If you remove this resonance structure, then it will look like this. So the negative charge will appear here. So, so these are the two isomers of amino acid and will have different physicochemical and spectroscopic properties as well as atomic connectivity. Let us discuss the types of tautomerization. Remember that the tautomerism is divided into two types. One is called as acid catalyzed tautomerization, and the second one is called as base catalyzed tautomerization. So on the basis of their catalyst, they are classified like this. We will discuss their mechanisms in our coming lecture.